Hi everybody, do you hear me? Interesting because I have a woman talking at the same time, so I don't hear myself. And thanks to be here for this talk about an evergreen cache. I'm Nicolas Fränkel. I've been a developer for 2 decades, and since a couple of years, I'm a developer advocate. This is our agenda for today. The first and the most important part is, why do we cache? Because some people say, oh, you are using a cache. You did a really bad job at architecting your... Like, only people who design bad system need a cache. Like, nice design system don't need a cache. That's completely wrong. So we will check some alternatives to keep the cache in sync, because in general you cache data from the source of truth, and yes, you want fast access. Then I will tell you a bit about a new solution to do that called change data capture. And I will talk a bit also about Debezium, which is an implementation of change data capture. And finally, I will show you how you can integrate it with Hazelcast. And I hope that I can impress you with a demo at the end. So first, caching is not bad per se, please. If somebody tells you caching is bad, yeah, they don't know anything. Caching, like any solution in IT, is a trade-off. It has pros, it has cons. And the most important trade-off in that case is we accept data that is stale, data that is not perfectly correct, but we get two benefits depending on the use case. Either we get fast data access, or we get data at all. We get available data. And my most used widespread use case in that case is the e-commerce shop. Because you decided to implement an e-commerce shop using microservices, because hey, who is not using microservices? Anyway, and so you have different components. You have the card component, you have the catalog component, checkout component, you have the payment component. And at checkout, your customer wants to pay, so you call the pricing microservice, and it's down. And it's not a good idea. So meaning you will lose a customer, you will lose a sale. So what is better? To lose a sale or to sell at a wrong price because you cashed the price earlier? I mean, if you are the business, it's better to sell, even at the wrong price. And imagine if you sell at the wrong price, sometimes it's a bit overpriced, it's a bit underpriced. At the end of the day, everything will be averaged. But most important of all, you will have sold. And in e-commerce, that's the most important stuff. So if you remember one thing from this talk is caching is a trade-off. Let's use a much simpler example. Here, I have a simple component. Hey, does it work like this? Yes. Ooh. So I have an application that reads from the cache reads from the database, and when I say read, it's read and write. And since the component, the application is the only component, like writing to the cache and then to the database, the cache is always in sync. That's perfect. That's the perfect use case. Unfortunately, probably you know that perfection is not of this world, and in general, your design probably looks like this. At some point, there is a batch, something else, that needs to update the data. Generally, it's reference tables. And then it breaks my perfection, because when I read from the cache, well, obviously, there is a chance that the bad job did change the data. And so the cache is no more in sync. That's a problem. So the biggest problem is how do we keep the cache in sync with the data store, the database, the source of truth, or however you want to call it. And you probably heard this quote before, that there are two hard things in computer science: naming things, cache invalidation, and off-by-one errors. In general, this is a joke. You should be laughing, or at least smiling. No, I see nobody. Yeah, I'm in Poland. We should be serious. I agree with you. And let me dive into the semantics a bit. I talked about cache invalidation, but there are actually multiple reasons to move like data away from the cache. The first thing is not cache invalidation. The first thing is cache eviction. When I tell you, hey, we have a performance issue there, we probably need to cache stuff, your first reflex is, let's use a hash map, or depending on your language, a dictionary, or whatever. Whoever did implement their own cache using a hash map. Don't be shy. Yeah, I mean, I thought everybody did, but there are like very serious people here. That's good. At least I did. And you soon realize it's a simple data structure. It's unbounded. So you put it into the cache and it will grow. And well, now you've got an issue because you use resources. You don't know how to remove them. The first thing that you need to think about is to put a limit on your cache. Now it's a bit harder than, hey, let's just use a hash map. You must use a wrapper, a decorator, whatever. Okay? Then comes the second question. You have a limit on your cache, and you need to put more data into it. What do? In general, you should remove one of the entry before to make place for the new entry. And it's cache eviction. And there are multiple strategies for that. Least recently used, least frequently used. You can have like custom one where every time you put a new entry into the cache, you put a priority. You remove in order of priority. There are a lot. So please don't roll out your own cache. Please. You remember, don't roll out your own crypto. You've seen it multiple times. Don't roll out your own cache. Just use a caching provider. First reason, cache eviction. But second thing, cache invalidation. Like if you put an entry into the cache, into a hash map, it will stay there forever. And so, if you put the data at one point from the source of truth and the source of truth changes regularly, they will probably diverge. And so there is a higher and higher chance with time that what you get from the cache is actually not wrong data, but very, very wrong data. How do we choose the correct time to live? There should be a background thread that removes entity from the cache. What's the correct time? Think about it. I told about my example with the bad job. My bad job runs every hour. If I say that 2 hours, that means that during 1 hour, I will have data that I know is wrong in the cache. Not good. On the opposite side, if I say 30 minutes, I will run one extra fetching from the cache, which is not necessary because I know that the data has not been changed. So the correct answer in that case is, hey, come on, folks. An hour, thanks. That was hard. Huh? You must be an engineer. Yeah, an hour. But it's bits more involved than that. Because the problem is only if you put the entry every hour. And in general, you don't do that. You get the entry from the cache when you fetch the data, which actually is, you don't know. Depends on the usage. So in that case, we should remove the correct ETL and say, let's go event-driven. And event-driven is the right way to approach the problem. Because in that case, if nothing happens on the source of truth, then you don't change the cache. But as soon as something happens, and it can be in rapid succession, then you update the cache. Sounds easy, right? The concept is easy, but how can we implement that? Well, if I'm telling you data and event-driven, like if you have done a bit of development around database, probably that sounds like a trigger for you. Like trigger is good. Something happens and you trigger something else. The problem that first, not all databases they implement triggers. So it restricts your choice. And perhaps you don't have choice. Okay, that works. But in general, and that's all the use case I've seen so far, is that triggers, they actually are meant to change the data inside the source of truth. But here, we want to actually change or update the cache. So how can we do that? Actually, for this talk, I checked if you could do it. And yes, you can. So I will be using the case of MySQL. It's possible. Of course, it's not really fun. You must develop your code in C++. I don't know about you, but I didn't touch C++ for 20 years. And I'm not really keen on touching it ever again. Also, there are a couple of restrictions and limitations and blah, blah, blah. If you want to know more, there is this whole article. But rejoice, somebody did it for us already. So on GitHub, you can find a project that is generic, and you just need to call this sysexec stuff. Again, you can find the reference here. I don't know how much it is used, how much it is reliable, if it's still updated, if people are still using it. So if I put on my architect hats, it seems to me that it's not a really good solution. Probably it might work as a demo, but it's too implementation dependent. As I mentioned, it's only for MySQL. Something that people don't care about in general, who will maintain it? And worse, if something is wrong, who will debug it? Because there are many people that are involved here. The developers, the ops people, the DBA team, who will be responsible? And again, triggers, not great. If you call them too frequently, they are really, really, really consuming. Now comes this stuff about change data capture. And here I've pasted the Wikipedia definition so you can read it, but I find it very hard to understand. I prefer it to define it in the opposite way. Who knows about event sourcing? If not everybody knows, then it will be harder. So the idea behind event sourcing is that you are redesigning the model so that instead of storing the state, you store events. So for example, I will take the example of a bank account. You will have an event created event. You will have, I don't know the term in English, like when you remove money events. And then if you replay all the events, like adding money and removing money, you will get the state. Point in time of my account 3 years ago. That sounds really cool. But of course, by doing that, you will actually need to completely design your information system. It will take a lot of storage. And every time you need to recompute the state at the current date, you will need to replay all the events. So there will be a lot of computing power involved. In general, you also take snapshots, so the computing power is not that much. You only need to take the latest snapshot plus the few events that happened. So it works, but it's not that great. On the opposite side, you have change data capture. So Event sourcing is you get the state out of events. Change data capture is you get the events out of states. Every time you do a change, you keep your model as it is, you keep your legacy, MySQL, Oracle, whatever. But every time you do an update or an insert or whatever, something that changes the state, you get an event out of it. And there are quite few implementation. So the first three, probably you all used them before. If you have a batch job that polls your database and that worked on a version, on a timestamp, on a status, does something and then updates it, that's considered change data capture already. Triggers. Triggers is also a way to do change data capture. But the implementation that is of interest to us today is log scanners. So what's the idea behind log scanners? There is this article on the internet from Martin Kleppmann, really good article, and Martin Kleppmann is really a good author. And basically, he talks about the SQL abstraction. And that SQL is all about interacting with the data store, but SQL is not about, hey, how do you cluster your data? How do you replicate your data? It's not about high availability. This is an important stuff, even for developers. You really should understand, I mean, how reliable is the data? What happens if I do a SQL query and there is a timeout? And actually, the DBA or the ops team are the ones who are interested about this kind of stuff. And how is it achieved? Well, for SQL engines, most of the time, when a SQL engine receives a change order, again, inserts, update, whatever, then the first thing it does, it writes it into a write-ahead log. That's the first thing it does. Now, if it fails at some other points, you can restart the engine and it will read from the log and still be able to apply the changes. But there is another reason for that, it's replication. Because it will write in the log and then there is like a slave that will read the same log and they will both apply the same statements in the same order. So at some point they will reach the same state. That's eventual consistency. So this log actually contains all the change events from a database. And as I mentioned, it can be about data recovery or replication. So one easy solution is, what if we hacked the log? That could be interesting. Okay, let's hack the log of MySQL. So here you can recognize some stuff, probably. Updates, where, some stuff that is not meant to be usable, and stuff that is completely not usable at all. So it's like the Rosetta Stone. If you know about some of the documentation, you understand that, otherwise you are lost. So you can tell me, hey, it's the same problem as before. It's implementation dependent, it's fragile, and who will maintain and debug it? Well, for the last question, I have an answer. It's called Debezium. I don't want to care about how it's done. I want somebody to do it for me. And Debezium is a component. So it's a Java library, and actually it's an abstraction layer over this kind of stuff. You will get an API that is database independent, and you just need the connector to the right database. Initially, the idea behind Debezium is it would live in a Kafka cluster, so every time there is a change in one of your data store, you would be able to write into one of those, let's say, Kafka channel. I forget the name, sorry. And of course, you can create multiple events in different channels. You can like write multiple databases into the same one. It's not important. That's the idea. Only thing that you need to do, and I need to say that I actually forgot to move it. Oracle is now production ready, is to have a driver, a connector that connects this exact database to the Debezium API. Point on, it's super easy. You just need to use the library. But again, I probably don't want to do that by hand. I want to get the data somewhere. The problem if you get the data from the database to Kafka to your cache is that you're actually introducing a level of, like, let's say, of slowness. Why don't you want just to take the data from the database to your cache? So in many cases, Kafka might be useful. In many cases, Kafka might not that be useful. I know Kafka is now the magical recipe to every one of your data problem. Again, it has pros, it has cons. You must decide in your context whether it's the case or not. Anyway, here I will probably have implemented the cache in one technology, and here I will be using Hazelcast since I'm working for Hazelcast. It's an in-memory data storage, key value store, but you have queues or whatever. And then it's a streaming engine as well. It's by Essence, it's distributed, and it's available under the Apache v2 license. So everything that I will be showing you is completely free and open source. Of course, we have an enterprise offering, but I don't want to sell anything. That's not my job. I don't get any commission. So here, this is the Hazelcast platform. Again, here, batch and stream processing. And here in memory data store, you get data from any of the source and you write it down into any of the source. So here we can say, hey, one of the source is like database events, and we will write it down into, I don't see it, but you can probably see it better than me, into Hazelcast, the data store, the in-memory data store, the cache itself. Hazelcast has two main deployments strategies. Who here is a Java developer? Not that many. Okay, that's good. So if you are a Java developer, it's very easy. You use Hazelcast as a library. You put it on the class path. When you start the application, you start your node. Auto discovery, they will form a cluster, and then you can use it. That's great. That's how you start playing with Hazelcast if you are a Java developer. But the problem that I mentioned before is soon your application and Hazelcast, they will compete for memory. They will run into the same JVM. So in general, when you start like relying on a Hazelcast for like serious purpose, what you do is you have dedicated cluster, and so your application becomes just a client. And here I wrote Java client, but I should remove it. You can use any of the bindings, and we have several. Python, who here is a Python developer? Okay. Like C++, good. Node.js, no JavaScript developer, interesting. Go, one person. I thought it was more popular. And C#, wow, I'm in, I'm in assembly of C# developers. Anything, any of those languages you can use with Hazelcast. For the streaming part, all streaming engines probably have the same concept. They might use different semantics, but they have the same concept. The first thing is they have a pipeline. So the pipeline is how you declare your code, where you will be reading from, what transformations you will apply, and where you will be writing to. Once you are ready for that, Angel, you package this code, and then you've got an SDK to send it to the cluster. The cluster will receive the code. It will interpret it and distribute it all over the cluster because it knows about the topology, and off you go. And now that brings us back to our use case. So I still have my application, I still have my cache, I still have this component that, like, I wouldn't say fuck my cache, but breaks my cache. And then what I will just add, I will add like a job that reads from the bin log and writes to the cache. So every time this component writes into the database, the job will write into the cache. So the application will always be reading good data, not stale data, up-to-date data. Shall we do it? It's the time where you should say yes. Otherwise, it's the done. Yeah, look, I was for 1 year and a half, I was at home talking to my screen, doing talks to my screen. Now I see people. And of course I want to interact with them, but I forgot that it's Poland, so that people, they don't want to interact. You want to stay in your corner, and of course you have those tasks, but okay. So next time I ask a question, please just answer at least one person, okay? Yeah, thanks. That was the next question. Okay, so let's do this stuff. Now the screen should change, and here I am in IntelliJ, and I very, very stupid application. So this application is actually a CRUD application, and here I have everything under Docker Compose up. So this Docker Compose consists of several things. I have this application. I will show you the codes. Even if it's Java code, I don't think it's very important or very hard to understand. I have the application that I have Dockerized. I have the pipeline, the stuff that reads from the database and writes to the cache. Here, I won't show it. And here I have the database. So the first thing I want to do is I want to stop the pipeline because I want to show you that, hey, without the pipeline, it doesn't work. So Docker Compose, stop pipeline. I will start it afterwards. Okay. The application is here. And that's the most important part, is the repository stuff. So like most of you are not Java developers, so I will tell you about it. Here I have my repository, and I have a component that allows me to read from the database and to write to the database. And here I have two caches. The first one is the entity cache. The second one is the query cache. Here I'm just trying to be smart, but it's not necessary. The first thing I'm doing when I'm trying to find all the entities in my database is that actually I will check into the query cache. Does the query cache contain something? In general, it doesn't contain anything on the first run. So what I will do, I will query from the database, do some magics that I create a new person, blah, 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 gets the data from the database, create this new entity, and put every of those entities into the other cache, the entity cache, with the key like the ID and the value, the person. Then afterwards, I put the query into the query cache, where the key is the query itself, and the values are the list of keys. Now, if it already contains it, what I'm doing, I get the list of all IDs from the query cache, and from the entity cache, I get all the persons. So I added an additional stuff. I added the query cache because I'm trying to emulate what a Java component does, which is called Hibernate. It's not necessary, but yeah, that's fun. And here, when I save the stuff, what I do is I put all the stuff into the query cache, into the entity cache, sorry. Okay? So let's see now how it works. And I hope it works, because normally it should have stored something. That's bad. That's really, really bad. You remember when I told I will try to impress you with a cool demo? Well, that's supposed to be now. That sucks a lot. So now, and here I'm supposed to be on 8080. Okay, let's try another time, and then Let's try again. I was trying to be smart, but perhaps I'm stupid. So the application has started. Perhaps there is a connection issue. So let's try. I wanted to check before if it worked without internet access. Yes, so it works with internet access. It was just that stupid stuff. Okay, anyway, now what I want to do is I want to stop the pipeline. Docker compose stop pipeline. Okay. Sorry. So here, first thing, Johnny updates. Something important, when I update, I do the post redirect get. So I reload the whole page, like you should always do, just to know that the stuff is really there. And next one, I have created a stupid application that actually can like do like emulates the batch job. So what I can do here, let's say I can update the second line with Chiara. So here is Jane. Now I have this job that will change the second line to Chiara. And of course, here, if I refresh, I still have Jane because I'm reading from the cache. And here, in the database, we have Chiara. Not good. So now, what I'm doing is I will start the pipeline. Start Docker compose, start pipeline. Okay, and how does the pipeline look? Well, the pipeline is actually, even if you are not Java developer, is pretty easy to get. So I assume that even if you are not Java developer, you know that in general in Java we have a main method. And here it's like a simple Java class. It has a main method. And here we get to create a new node for the cluster. I'm doing that embedded. I'm using the first deployment model because it's just a demo. And I create this job from the pipeline. And the pipeline, how does it look? Well, it reads from the database. Here, because it's streaming job, we don't care about the timestamp peak. We write down the data into the log. We map it to a person and then to a map entry, and we write to the cache. So even if you are not Java developers, you can understand the steps. Reading from the database, okay? Well, I'm just using like the Jet API, the Hazelcast Jet API. The rest is just configuration. And again, for the rest, writing to the cache is we use the exact same cache as we used like for the application. So now what I'm doing is I will refresh it and I have Chiara. Because now the job is running. And every time I do a change, not here but here. So let's say I will update 3 to Robert. Now I have an update cache. The cache is always evergreen. Whatever happens on the database, it will be streamed and put into the cache. Dobrze? Sorry, I don't know so much Polish, so... Okay, so this was it. Summary, recap, important stuff. I told you the caching trade-off. If you do caching, you are not a bad architect or a bad developer. You just understood that in this context, you prefer availability or speed over freshness of the data. That's good. But change data capture can actually cope with this problem. So you can have the best of both worlds. I hope so. And I've shown you the implementation with Hazelcast. So thanks for your attention. You can read my blog. You can follow me on Twitter. More importantly, you can check the GitHub repository. It really works. You can do it by yourself, get the source code, build everything. It will work. And if somehow I got you interested about Hazelcast, join our Slack channel, ask questions, or get some free training. And now it's time for the most dreaded part of the talk, especially here in Poland. Do you have questions? Yes, thanks. You saved my life. Yeah, I can come closer.
Can we go back and look at the slides?
Yes, which ones?
One at the beginning where you've written like the...
Okay. The deployment model. This one, yes.
My question is, do you just update the chat cluster? Does it just run on the updates from the XYZ? Or does it run just generally on every change thing?
Okay, so the question that the gentleman asked is that the job here, does it read only changes from this component or it reads anything? And the answer is it reads everything because it reads the bin log. So you can subscribe on specific tables to say, oh, I will only want to, I'm only interested in this and this table. But otherwise, you can have multiple components writing to the same table. You will be aware of them.
Okay, then my follow-up question is, I'm not sure if I see the sense in having I'm not sure if it's duplicate data, but basically we're getting data from two sources, and we are storing it in two sources, kind of the cache and the database. My thinking was that we only write to cache when the cache is invalidated, right? Not on every event ever.
That depends on what you want to do.
Okay.
Like here, you could have additional data when you write, saying, hey, I wrote from this, and then you get the event from the bin log, and Jet can filter. So you can apply transformations here that say, hey, I don't care for this, but I care for this. Or then I change the format. Here we get from a specific entity, and we write it down into another format here.
Okay, that's good. So it's customizable. Thanks.
Thanks. Other questions? In general, well, yes. Can you give the mic to the gentleman, please? But I don't have anything to hear. If you could speak real loud for me. I'm old.
Yes. What are the drawbacks of this solution?
That's a good question. What are the drawbacks? Actually, it's not really a drawback, but the only thing is that it's not instant. Light takes time to get from one point to another, but the network even more so. So here, because we are talking about distributed systems, when the component writes here and the database writes into the bin log, it takes a bit of time to read and its eventual consistency again. But the window of inconsistency we reduce to the smallest window possible. So I cannot guarantee you that you will be reading the latest prices, exactly as they are, but I can guarantee you that the time between the time frame when the prices are not in sync is the smallest possible, which is much better than polling regularly. That's questions.
I have more
Other
questions. I have more questions.
Another question for the same gentleman, and again, I need to come further because I'm completely deaf.
Right.
Or even better. But
okay.
it kills all interactions.
Yeah, sorry for that. So now I don't have to shout. So how does it compare to the performance of these databases which have event triggers embedded? Is it really a difference?
Okay, so I didn't do any benchmarks, but the problem with triggers, as I mentioned, is that they, they were not designed for that. The triggers, they are designed to react upon stuff and change it in the database. Here, as I showed you, you call another process. And it's very, very fragile. I've shown you only with MySQL, it's going to be a mess. So it's not even about performance. Here, it's about fragility. Here, this is much more robust because Jet was designed for that.
Okay, thanks.
Other questions?
Podajcie tam dalej, proszę.
What about collisions? For example, if you just add one to a value in a database from another source, or echo. Sorry, echo. Do you understand? And another client wants to add one to a value in the database. How to achieve this?
So there is no magical solution in that case. You have the same when you are just using a plain database. Hey, I want to get
There's a
value
transaction.
to
Database should implement transactions.
yes. And with a single database, you have got the simple issue. You need to lock. There is no other way. But with locking, it slows down. So now we've got another trade-off, folks. What do value more? Like speed or consistency? And depending on your context, you might value more speed, but we are more used to consistency. But once you will scale, you will probably value more speed. So it depends on your context. Here you can do the same. You can also have locks in Hazelcast cache, but it will slow down. No magical solution. Other questions? No other questions? 3, 2, Adin? No questions. Thanks a lot.